Hello, Bacho. Let's read this question. It says, consider a simplified model of the cloud formation. Hot air in contact with the Earth's surface contains water vapor. This air rises convectively till the water vapor content reaches its saturation pressure. When this happens, the water vapor starts condensing and droplets are formed. We shall estimate the height at which this happens. We assume that the atmosphere consists of diatomic gases, oxygen and nitrogen in the mass proportion 20/79 respectively. We further assume that the atmosphere is an ideal gas. G is the acceleration due to gravity is constant and air processes are adiabatic. Under this assumptions, one can show that the pressure is given as P is going to be T naught minus of Pz over T naught to the power alpha, where P naught and T naught is the pressure and temperature respectively. At sea level, Z is going to be 0. T is the lapse rate, magnitude of the change in the temperature T with the height Z above the Earth's surface. That is the T is greater than 0. So according to this model, what is the height to which the atmosphere extends? Take T naught is going to be 300 Kelvin and P naught is going to be 1 atm. Okay, so now here, the key concept which we are going to use is what? Temperature with lapse rate. Okay, so we know that the temperature is going to change with the lapse rate. Like for example, we can suppose that the temperature at the point where the atmosphere is end, right, extends, or so we suppose there is the temperature is minimum and the minimum temperature is like 0, right? And the temperature at that point will be calculated as what? That will be what? T naught minus of lapse rate Z is going to be what? 0, right? So we can say that the T naught is going to be what? Lapse rate times Z, and that the Z we have to calculate. Z will be what? The T naught divided by the lapse rate, right? The lapse rate we have already calculated, like that is a change in the temperature ongoing just for 1 kilometer, right? You can say for change in 1 kilometer, the lapse rate we have what? 9.9 Kelvin for this situation. Okay, if we are going on top by 1 kilometer, then this is the change in temperature. So we have the initial temperature as 300, so it should be divided by 9.9. Then what we will get? We will get something around 30.3 times 10 raised to the power of 3 meters, right? So Z will be what? Z will be, this is the Kelvin per kilometer, right? Per kilometer, right? So this is the answer we get. So it means we will, the atmosphere extends to the 30.3 kilometers level. So this is the answer for this question. I hope you understand it well. Best of luck. Thank you.